Good evening. Welcome to this video segment. My name is Samuel Chukwu Emeka. In this segment, we shall talk about radicals. Before you view this segment, I recommend that you view the videos on roots and also the videos on numbers and notations. Okay, so it will be good if you view the videos on those topics. So, what are radicals? Radicals are just roots. I mean, a radical is an expression that uses a root. A radical, it simply means a root of. Any expression that uses a root is known as a radical. Some textbooks will call it swords. In Nigeria, we call it swords. We also call it radicals. Now, if it is a sword is an irrational root. That is typically the difference between a radical and a sword. Or you can say that a sword is also a radical, but irrational roots, irrational radicals. Now, if you want to know what irrational numbers are, please view the videos on numbers and notations. Okay? All right. Now, let's say we have square root of 12. Of course, the symbol here means 2. I hope you know. It means the same thing. Whether if you have it this way or you have it this way, it means the same thing. Okay, now, this symbol right here, this symbol is what we know as the radical sign. That is the radical sign. 12 is what we call the radicand. And then 2 is what we call the degree. Let's do another example. If we have cube root of 50, this symbol is what we call the radical. That's the radical. 50 is what we call the radicand. And then the 3 is what we call the degree. Okay. Now, let's solve questions. If you were told to simplify square root of 12. Okay, you look at 12. 12 is not a perfect square. If it was a perfect square, like 4, square root of 4, you can easily say the principal square root is 2, or the positive square root is 2. But if you are given something like square root of 12, then that is where you need to simplify it. Simplify this radical. So, for us to simplify radicals, we have to find 2 factors. And it will be good if you also view the video on factors and multiples. So we have to find 2 factors of 12. So let's begin to list the factors. Okay, 1 and 12. Right? Let's just list the factors of 12. Then 2 and 6. 3 and 4. And I think that is it. Because 1 and 12 means 12 and 1. Alright. Now, we now have to find out which of these 2 factors has a perfect square. Okay? We did perfect squares in a video on roots. So you need to view that video. So which of these 2 factors has a perfect square? Now, I know that 1 is a perfect square, but we are not concerned about 1 because 1 and 12 will still give us 12. It doesn't simplify the problem, okay? it doesn't simplify it because we still have 1 and we still have 12. So besides 1 and 12, so let's cross out this. Which of these two factors now, we have two pairs of factors here. Now, which of these two pairs of factors has a perfect square? And you see it is 3 and 4. So from the rules of sorts, one of the rules of sorts, okay, one of the rules of sorts says that square root of AB is the same thing as square root of A times square root of B. I'm still going to talk about this later on the second video on radicals. So square root of 12 means square root of 3 times 4, and it's the same thing as square root of 3 times square root of 4. Okay? So this will now be what? If we complete this, let's write it again. Square root of 12 is the same thing as square root of 3 times 4, which is the same thing as square root of 3 times square root of 4, which is the same thing as square root of 3 times 2, which is now 2 square root of 3. And this becomes our answer, 2 square root of 3. Now, some people might say, why not I write square root of 3, then 2? Okay? And then 2 square root of 3. Okay, this, we don't write it this way. No. This is no. And this is yes. So, when we have a radical and an integer, we write the integer number first. Okay? It's just like 2 times a will give you 2a. If you have 2 times a, it gives you 2a. You don't want to say 2 times a and you say a2. A2. We don't want to say it this way, a2. No. We want to say 2a. So we want to put the integer first before the radical. Okay? Now let's do another question. What if we have negative square root of 28? Negative square root of 28. Now, like I said earlier in this video, I am going to deal with only integers, positive integers, right? But you can have a negative outside the radical. It doesn't matter. So if you have a negative outside the radical, it means negative 1 times square root of 28. That is what it means. So let's go ahead and find out our square root of 28. Before we find out our square root of 28, let's find the factors in which at least one of them is a perfect square. So let's forget about 1. We have 2 and 14. 2 and 14. 2 is not a perfect square. 14 is not a perfect square. 3 cannot divide 28. 4 and 7. 4 and 7. So we see here 4 is a perfect square. And because 4 is a perfect square, we will use 4 and 7. So this means now negative 1 times square root of 4 times 7. So this means negative 1 times square root of 4 times square root of 7. So this means negative 1 times 2 times square root of 7. So this means what? Negative 2 square root of 7. And that becomes your answer. Negative 2 square root of 7. And that becomes your answer. Sometimes we may have radicals that just cannot be simplified. For instance, let's look at a square root of 30, for instance. So let's list 30, factors of 30. Forget about 1 and 30. We have 2 and 15. 2 is not a perfect square. 15 is not a perfect square. We have 3 and 10. 3 is not a perfect square. 10 is not a perfect square. 4 cannot go. We have 5 and 6. Okay, then 30 and 1. Forget about 30 and 1. Now, so you see, these are the factors of 30 besides 1 and 30. Okay, and none of them are perfect squares. None of them are perfect squares. So if you have square root of 30, I mean, you just write cannot be simplified further. You cannot simplify it further because there is no perfect square that is a factor of 30. Okay? What if we have negative square root of 46? Now, this means what? Negative 1 times square root of 46. So you want to find 46. What are the factors? We have 1 and 46. Forget about that one. Then we have 2 and 23. Right? 3 cannot go. 4 cannot go. So it's just 1 and 46, 2 and 23. So you see 2 and 23 are not, 2 is not a perfect square. 3 is not a perfect, 23 is not a perfect square. So 2 is not a perfect square. 23 is not a perfect square. So you see that this, I mean, negative square root of 46 cannot be simplified further. Cannot be simplified further. Let's do more examples so that it will increase your understanding of this. I suggest that, you know, when you view my videos, before you do a problem, before you watch me do a problem, you pause the video, pause it, and attempt it on your own before you now view it, okay? That will help you to kind of gain more understanding on it. So that if you make any mistake and then you watch me do it, then you can find out your mistakes. And that is the way you learn, when you can find out your mistakes and you make sure you don't make those mistakes anymore. Okay? Now, the next one, let's simplify square root of 288. Right? We do it the same way. We find the factors of 288. And we have 1 and 288. We forget about that one. Then we have 2 and 144. So this is kind of a straightaway stuff. I mean, 2 and 144. It's kind of straight away because 144 is a perfect square. So we now say that it's square root of 2 times 144. Which is square root of 2 times square root of 144, which is square root of 2 times 12, which is 12 square root of 2. Remember, you write the integer before the radical. Okay? What if we have negative square root of 48? So this means negative 1 times square root of 48. So let's find the factors of 48. We have 1 and 48. We can forget about that. We have 2 and 24. 2 is not a perfect square. 24 is not a perfect square. We have 3 and 16. And there you go. We use this. I mean, when we find a factor, you know, sometimes it might not be necessary for us to keep listing the factors. Now, we are going to do several examples, and I will tell you what to do if you have two factors that are perfect squares, okay? But here, 3 and 16, it makes sense. Square root of 16 is 4, and then 3 is not a perfect square. So this is negative 1 times square root of 3 times 16. Negative 1 times square root of 3 times square root of 16. Negative 1 times square root of 3 times 4. Negative 1 times 4 times square root of 3, which is negative 4 square root of 3. I'm kind of breaking it down. I know I can easily say the answer, but I am just breaking it down, okay? What if we have negative square root of 375? Now, you know, when you deal with large numbers, you probably don't want to start listing all the factors of 375. 2 will not go, but you do 3 and 125, right? You probably don't want to waste time doing this. So, another thing you can do is, why don't you just find the perfect squares and see whether any of those perfect squares is a factor of 375. How about that? You know, let's kind of list the perfect squares and see which one of them is a factor of 375. Because some of these big numbers might have a lot of factors, and if you're working under time, you know, you don't want to come and start listing 3 and 125, 5 and 75, you know, and you go on listing. So you can just say, okay, and most times you are not allowed to use your calculator to do radicals. So just let's list the perfect squares, okay? We have 1, but we don't need 1. 4, 9, 16, 25, 36. And as you're listing them, right, you find out, okay, which of these perfect squares are factors of 375, so as to save you time in this listing. So as you can see, we have a 25 already. 25 is a factor of 375. And of course, we have a 25 and 15. So we use it immediately, you know. 15, if we look at 15, it's 3 and 5, which are prime numbers. We can't deal with it. Okay, 3 is a prime number, 5 is a prime number, and that makes 15 not to be simplified anymore. So we just use 25 and 15, and this gives us negative 1 times square root of 375, negative 1 times square root of 25 times square root of 15, negative 1 times 5 times square root of 15, negative 5 square root of 15. Okay? Now, what if we have this, let's say square root of 96? Okay, let's say we don't want to list it, since there, an easier way would be to just see whether any of the perfect squares is a factor of 96. Now, if we begin to write our perfect squares, 1, 4, 9, 16, 25, you know, and of course, we don't need to go further because it might not be what we need for 96. 96 is a small number. But if we look at this situation here, we see that 4 can go. 4 can go. 4 is a factor of 96. We have a 4 and a 24. And we also have a 16 and a 6. So if you encounter a situation whereby you have more than one factor, you have more than a pair of factors that are that has a perfect square. Like here, we have 2 pairs. Okay, so if you encounter this situation, then I advise you, I'm teaching you to use the largest one. So, and the largest one is this, 16 and 6. Okay, so we now use it. And if we use it, it's going to give us square root of 16 times 6, which is square root of 16 times square root of 6, which is 4 times square root of 6, which is 4 square root of 6. Of course, you can simplify further. You can simplify square root of 6. Now, but that does not mean that if you use this, you won't get it right. No. If we use 4 and 24, we will get it right. But guess what? we will have to simplify 2 times. Okay, that's the situation with this. So if we do 4 and 24, that means we'll have to simplify 2 times. I'm gonna show it to you here. If we have square root of 96, and then we have square root of 4 times square root of 24, square root of 4 is 2 times square root of 24, and then you have to simplify this again. Square root of 24 will be of course 4 and 6. So you see, square root of 4 times 6, which is 2 times square root of 4 times square root of 6, which is 2 times 2 times square root of 6, which is 4 square root of 6. So you see, this one wastes more time. In life, and especially in mathematics, you really want the one that will kind of save you time. But that doesn't mean that this will not work. It will still work. Okay? What if we have a 6 square root of 72? So this is not different from what we have been doing. The only thing is that what we have been doing is like 1 times. You know, like if you have square root of 72, it means 1 times square root of 72. But in this case, it is now 6. In this case, it means 6. So this means 6 times square root of 72. Okay, so if we look at 72, of course, we have a 36, because 36 and 2 is kind of the fastest one that we need. So this is a 6 times square root of 36 times 2, 6 times square root of 36 times square root of 2, 6 times 6 times square root of 2, which is 36 square root of 2. Okay? I'm trying to do several examples so that you won't get, you will understand it very well. What if we have a negative 6 square root of 150? Now this will be negative 6 times square root of 150. Now, of course, from the way we now use 1, 4, 9, 16, 25, we stop at 25 because 25 can divide 150. So, and it's 25 and 6. 25 and 6. So this is what we're going to use. So this is negative 6 times square root of 25 times 6, which is negative 6 times square root of 25 times square root of 6, which is negative 6 times square root of times 5 times square root of 6, which is now negative 30 square root of 6. Now, let's look at cube root, because it's still a radical. Of course, like we said, radical means root of that. Okay, assuming we have cube root of 40, for instance, cube root of 40, to simplify. In this case, of course, you want to list the factors such that one of them is a perfect cube. A perfect cube. Remember, perfect cubes, if you view the video, 1 cube is 1, 2 cube is 8. We don't use 1 anyway. 3 cube is 27. 4 cube is 64. 5 cube is 125, and the rest of them. So, if we look at this now, which of these factors, is a factor of 40? So we see it's 8 and 5, right? 8 times 5 is 40. So this will be a cube root of 8 times 5, right? So this is a cube root of 8 times a cube root of 5, right? So this is a 2 times cube root of 5, which is what? 2 cube root of 5. That becomes the answer, 2 cube root of 5. What if we have a negative fourth root of 512, 512, negative fourth root of 512. So we look at perfect fourths in this case. we look at perfect fourths. 1/4 is 1, which we will not use anyway. 2/4 is what? 16, right? 3/4 is what? 3 times 3, 9 times 3, 27 times 3 is 81. Now, I think, but 16 can divide 5/12, actually. 16 can divide 5/12. But let's try 4/4, okay, which is 256. So in this case, we see at least two things that can go. 16 and can go. 256 can also go. And remember what I told you in this case: when you have more than a factor, more than a pair of factor, right, that has a perfect square, choose the highest one. Okay. Now that doesn't mean if we choose 16 and the other factor that it will not go. No, it will go. 16 and 32 can work. 256 and 2 can also work. But if you want to save time, you want to just do 256 and 2. So this will be -1 times 4th root of 512, which is -1 times 4th root of 256 times 2, right? Which is -1 times 4th root of 256 times 4th root of 2, which is -1 times 4th root of 256 is what? Is 4 times 4th root of 2. So the answer will be -4 4th root of 2. Let me write it over here. -4 4th root of 2. This becomes your answer. Okay. But what if we decide to use 16 and 32? You will see it will take us more time. Let's try it. So we have a -4th root of 512, and we have a -1 times 4th root of 512, and we have a -1 times 4th root of 16 times 32, and we have a -1 times 4th root of 16 times 4th root of 32, and we have a -1 times 4th root of 16 is what? 2 times, we have to simplify 32, which is 16 again and 2. You see, that's the next, that's the, and we continue from here. -1 times 2 times 4th root of 16 times 4th root of 2. I hope you're seeing this well. So this is -1 times 2 times 2 times 4th root of 2, which is now -4 4th root of 2. The same thing, but this is more tedious. Okay. Okay, this will be our last one actually. What if we have a fifth root of 486? Right? Fifth root of 486. So just we do it the way we've been doing it. Let's find perfect fifths. Perfect fifths, we have one which we will not use. 2/5 is 32. 486 divided by 32 will give you a 243 divided by 16, and it won't. It's odd number and even number. No, it's not gonna work. It's gonna be a decimal. 3/5 will be 243. Wow. Yeah. So this is gonna work. 243, right? So, and it's 243 and 2. And 2. Okay, so this will be fifth root of 243 times 2, which is fifth root of 243 times fifth root of 2, which is 3 times fifth root of 2, because fifth root of 2 for the 3 is 3, because 3 raised to power 5 is 2 for the 3. So this is 3 fifth root of 2. Alright, thank you for listening to this video, and watch out for other videos I will do on radicals, especially as it concerns variables, okay, and also negative radicals. Thank you for listening, and you have a good evening. Bye.